Hello. I thought I was done for the night, but I remembered I have one more video to correct. It is on lesson outline number 7, matter and energy. Here is the practice book, lesson 7, page 313 through 318. I'm going to give you the answers here. Please get your book out, go over your answers, make sure you got them right. If you didn't get them right, understand why you didn't. Number 1, on lesson outline page 313, a battery provides electrical energy. Okay, if you put chemical energy here, I can see why you'd put that, because it has chemical energy, a chemical reaction inside of it, but it provides electrical energy. Number 2, the chemical reactions in a battery produce electrons, each of which carries energy. So those little particles are electrons, and they carry energy and go around. Number 3, when a battery is connected to a light bulb with wires, a closed circuit is formed. When it's connected, it's closed circuit. When it's not connected, it's an open circuit. 4, when electrons in a circuit pass through a light bulb, they give up some of their energy to the wire in the light bulb called the filament. The filament is the wire inside the light bulb. Number 5, the ammeter measures amps, telling us how many electrons flow each second. And 6, the voltmeter measures volts. Okay, so ammeter measures the flow, voltmeters measures the potential difference. Number 7, energy is a measure of how much work something can produce. So energy, which is measured in joules, is a measure of how much work something does. 8, work is using forces to move an object, either push or pull. Number 9, energy is not a type of matter. That's very important. Energy is not a type of matter. Okay, type of matter could be like, solid, a liquid, a gas, or whatever. Energy is not a type of matter. Very important to get. Number 10. Any moving object has kinetic energy, and 11, stored energy is referred to as potential energy. Next page, we're flying through. 12. The transfer of thermal energy from one object to another is called heat. Thermal energy is another word for heat. 13. Heat always flows from hotter materials to colder materials. Never the other way, because cold or cool is just an absence of heat. You can't transfer cool to something. You take heat or thermal energy away. In 14, in conduction, thermal energy flows through objects as their particles vibrate. So conduction is thermal energy passing from particle to particle to particle. In convection, hot parts of a material rise while cooler parts sink. So convection is when the material itself moves. 16, heat is transferred through electromagnetic rays in radiation. 17, metals are the best conductors of heat. And 18, the molecules in solids are packed very closely together. So they can transfer energy a lot more easily in solids. It actually works in sound too. Sound can travel a lot better through a solid than a liquid or a gas. Page 315. How do electrons flow through the circuit? Essentially, wanted you to describe what's happening. A chemical reaction happens in the battery. You don't have to have this word for word, but kind of something like this. Chemical reaction happens in the battery. The electrons leave through the negative terminal. They go out around the wires to the positive terminal, and they go through the light bulb and the filament in the light bulb in the meantime, giving it light, and it goes back into the battery for the chemical reaction again. 2, the filament gives off what kinds of energy? Okay, what kinds of energy? Now, the kinds of energy you have are mechanical energy, chemical energy, thermal energy, radiant energy, chemical energy. Did I forget any? Oh. But what it gives off is, what does a light bulb give off? It gives off light, and if you had the old style of light bulb, at least it gives off heat. And so, what are light and heat? Light is radiant energy, heat is thermal energy. Number 3, would the light bulb work if you attached both of the battery's terminals to one side of the light bulb? Okay, if you attach them both just to the same side, it would not work because it's not a closed circuit. They wouldn't be able to flow in a circle. They just kind of they'd come out of the negative. Sometimes you might think they'd come out of the negative and the positive and just hit there, but they'd only come out of the negative and they'd have no way to get into the positive one. 316 now. This one might have been a little hard to figure out what it was. This is like a flame being given to something that's being heated, and the darker parts are the parts that are heated. So number one, which metal particles are the first to react to the heat? This is one of those pages that could have been a little confusing, and if you were a little confused by it, I wouldn't blame you, because sometimes the answers are just easier than you think. Which metal particles are the first to react to the heat? The ones that are closest to the flame, right? First ones you could have said on the left or whatever. Just basically describe the ones that are closest to the flame. How do they react? And by the way, this is like the same picture. It's not meant to be three different things being heated. It's meant to be early, a little bit later, and a little bit later after that. Number two, how do they react to heat? Well, they start moving. That's why they look a little blurry. They move about rapidly and start colliding with their neighbors. It's kind of hard to tell if they're moving. But number three, how does heat travel down the piece of metal? As the particles collide, they bump one another and they pass that thermal energy to their neighbor. 317. You can think of, that's conduction. You can think of it as like, let's say you're standing in a very close line and somebody bumps into somebody behind them. They bump in, they bump into one another, and they would eventually bump. That's like conduction. Number one on page 317, the ability to move matter around is G, energy. Energy moves matter around. Two, when hot parts of a material rise, but cooler parts sink, that's D, convection. Three, the energy of a moving object, A, kinetic energy. Four, a thin wire in a bulb is a F, filament. Five, energy stored in an object or material is B, potential energy. Six, when heat is transferred through electromagnetic rays is E, radiation. We know that radiation is transferred to electromagnetic rays. That's the only type of heat, thermal energy, that can actually move through space. Conduction and convection does not work in space, only radiation. 7, which is how sunlight gets to us. 7, movement of energy from a hot object that comes into contact with a cooler object. The material remains in place, would be C, conduction. Identify the form of energy and write one way to use that kind of energy. This one's a little bit tricky to figure out. Again, this would be a section that we would probably go over together in class, but you had to list two things for each line. The first thing you have to list is what type of energy. Remember, mechanical, electrical, thermal, radiant, chemical, whatever. You had to list one of those, and then you had to give an example of how you would use it. So the first one, carried by light energy. What would light energy be? It would be called radiant energy. The official name for it is radiant energy. And how could you use it? Right now I have lights on. A flashlight, light bulb, whatever, that is radiant energy. Just to give it an example, you could have said a light bulb, a light, whatever. 9, stored in links between atoms. Okay, if it's talking about atoms and electrons and everything, it's not electrons, but atoms and stored in the links between them and broken and chemical reactions. This is a chemical energy, and you could give what kind of example? You could give inside of a battery. There's plenty of different chemical energies. You use chemical energy every day. When you eat food, you take chemical energy from that digestion reaction. You take chemical energy out of it. 10, the sum of kinetic and potential energy of a system. That would be mechanical, and mechanical is anything that involves motion or movement. Whenever you have kinetic and potential energy, remember I talked about this last time. When you are at the top of like something falling, let's say, the top is all potential energy, 100% potential is 0% kinetic. When it falls, when it's just the very bottom, like here's the ground, it's the instant before it hits, it's 100% kinetic, 0% potential. So when you add those both together, you get motion, right? And you have mechanical energy. Mechanical energy is the energy of motion. And you can think of it in whatever motion you want to do. Think of it riding a bike. You can think of it swinging on a swing set. You can think of it sliding down a slide. Anything that moves is mechanical energy. 11, carried by electrons in circuits. Electrons carry electricity. And so it's electrical energy. Electrical energy. The example that they want you to use is essentially anything that uses electricity. So you could just list anything. A microwave, a TV, your computer or iPad that you're listening to this on right now. Anything that uses electricity could be an example. And 12, heat produced by a filament. Now, you might have thought filament meant light bulb, and I would accept that. And by the way, type of energy would be thermal energy here, because heat, thermal energy. And you might have thought, as my example, I see filament, so I'll use light bulb. That's okay, that's accepted, but you really could have done anything that gets hot. And so you could have done an oven where you cook food. You could have done like a hot plate or something like that. Anything that gets hot. Last page. 318. What is energy? Energy is not a type of matter. Not a type of matter. It is a measure of how much work something can produce. To scientists, work means using a force, which is a push or a pull, to move an object. There are many forms of energy. When something moves, its energy is called kinetic energy. Another main form of energy is potential energy. This energy can be described as stored energy. An example of this is chemical energy, which is energy stored and linked between atoms. All right, that's it. That's lesson 7. And